All right, this is 11.4 hyperbolas, the last of our conics for this class. Definition of a hyperbola is the set of all points in a plane for which the absolute value of the difference of the distances from 2 points, the foci, is constant. The midpoint of the segment between the foci is the center of the hyperbola. Okay, whatever that all means, right? Okay. So we've been dealing with conics, circles, parabolas, ellipses, and now we're on hyperbolas. Okay. And not much has changed. A is still the distance from center to vertex. C is still the distance from center to focus. And what's not shown here again is the minor points, V. So let's go ahead and plot those. So here would be minor point 1 and minor point 2. And the distance from center to minor point is, of course, B. Okay. And what you can create between vertices and minor points is something called the fundamental rectangle. So if I just do some dashes here, we create a rectangle that cuts through the minor points and the vertices. And what's cool about this is that we have asymptotes that cut through the corners of this rectangle, and our parabolas follow those asymptotes. So, with that being said, when we start figuring out these hyperbolas, what equations to use, once again, knowing A, B, and C is definitely important. And then knowing which axis you're parallel to is also important. So knowing all of this will help us use either of these formulas. Okay, so everything I drew above is drawn below as well. So once again, A is the distance from center to vertices, B is the distance from center to minor points, and C is the distance from center to foci. Okay, so if you are parallel to the x-axis, your center is still HK, and you would look like this hyperbola down below. Okay, we know that the points, the vertices, the foci, the vertices and the minor points come when we start graphing them. Okay, but then one important thing is, what equation do you use, right? What's the equation to use? So if you are parallel to the x-axis, we use the first equation shown. X minus h squared over a squared minus y minus k squared over b squared equal to 1. And if we need to find a, b, or c, we use this formula. B squared equals c squared minus a squared. Okay. So notice this is kind of like the ellipse. We see that these are connected by subtraction, right? So our equation is connected by subtraction. Okay. Ellipses were connected by addition. All right. And then if you want to solve for your asymptotes, you would have y minus k equals plus or minus b over a times x minus h. This would give us the asymptotes that cut through the center and the corners of the fundamental rectangle. All right. And of course, if you're parallel to the y-axis, you will use this equation. Now, look at the difference from the one above it. It's y minus k squared, but still the denominator is a squared. So, nothing like the ellipse where the bigger denominator goes with the right variable. Okay, and again, connected by subtraction, and the asymptote formula is a little different. The only thing different here is instead of b over a, it's a over b. Okay. So once again, to take away, knowing a, b, and c is important. knowing which axis you are parallel to is very important, and connecting what axis you're parallel to in the equation, it all comes together. Knowing what pieces to work with will definitely help you out. All right. And for the first one, you have horizontal hyperbolas and vertical hyperbolas. So let's get started. All right, copy and pasted those formulas. So first up is find an equation for the hyperbola with the center at 1, -2, a focus at 4, -2, and a vertex at 3, -2. Okay, so again, it is just a lot easier to plot everything that we know. Let's see, I should have changed this up. Oh well. All right, so first I'm going to plot the center, 1, -2, right there. There's my center. There we go. And then I'm going to plot my focus at 4, -2. 1, 2, 3, 4, -2. There's my first focus. And then I will plot my vertex at 3, -2. 1, 2, 3, 3, -2. And there's vertex 1. All right, let's zoom in. And once again, remember the distance from center to vertex is A. So we know that A is now 2. The distance, whoa, wrong one. The distance from center to focus is C. So now we know that C is 3. So let me write these down over here. A is 2, and C is 3. Which also means, that means we can find B. But in the meantime, well, since we know the distance from center to vertex 1, we can find the distance from center to vertex 2. If it's 2 units to the right of the center, then the second vertex is going to be 2 units to the left of the center, right there. There is vertex 2. Same with the focus. If the first focus is 3 units away to the right, the next focus is 3 units to the left. 1, 2, 3. There is focus 2. Okay. Now, the other thing we should notice as well is if I put a line through these points, which axis are we parallel to? The x-axis or the y-axis? And it is parallel to the x-axis. So now this is giving us more information on what equation to use. All right. But first, let's go ahead and solve for B. All right. So I'll come up here. A is 2, B we don't know, C is 3, and using the Pythagorean theorem above, we can say that B squared is equal to C squared minus A squared, which would give me B squared equal to 9 minus 4. B squared would be 5. Therefore, B would be plus or minus whatever the square root of 5 is. Second square root 5. 2.24. So 2.24. Okay. So now we have A, B, and C. And now we can find the minor points. So we can go back down to the graph. And from the center, we'll go up 2.24 and down 2.24. So 1, 2, 0.24, 1, 2, 0.24. So minor 0.1, minor 0.2. And what I'm going to do right now is just draw the fundamental rectangle from vertices to minor points. This will just give us some direction on how our hyperbola should go. All right. But graphing is one thing. Let's go ahead and find the equation. We know we're parallel to the x-axis. So this means we're going to use the first one. Okay. So for the equation, we know that our center is already given at 1, -2. So we're going to have x minus 1 squared over a squared. We know a, so a is 2, so this will be over 4. Minus y plus 2 squared over b squared. We know b squared is 5, equal to 1. There's the equation. Now let's find the asymptotes. I mean, we want to find everything. Actually, yeah, so let's go through the whole thing. We'll list the foci, vertices, minor points, and asymptotes. So let's go through that. So from the graph below, we see that our center, which is given already, is at too big. Our center was at 1, -2. My foci were at, we were given what, -2, -2, and 4, -2. My vertices are given at -1, -1, and 3, not -1, -2, right? Sorry. -2, and 3, -2. And then my minor points were given at 1, so I can say 1 and -2 plus or minus the square root of 5. But if it wants decimal, you know how to put it in decimal format now. Okay, center, foci, vertices, minor points. Next is the asymptotes. Which is given by y minus k equal to, what do we have up there? Oops. Y minus k equal to plus or minus b over a times x minus h. So just plug in everything that we know. Y minus k, our k value here from the vertex is -2. So y minus, -1, or 1, -2. So yeah, so y minus -2 equal to plus or minus b over a. So I'll just make it square root 5 over 2 times x minus our h value from the center of 1. Okay. That's plugging everything that we know So we should get y plus 2 equal to plus or minus the square root of 5 over 2 times x minus 1. And this line would represent the asymptotes that cut through the center of my hyperbola. All right. And if it wants you to solve for y, well, just move that 2 over, distribute the square root of 5 over 2, and solve for y. That's it. Okay. So let's draw our asymptotes that cut through the center and the corners of the rectangle. And then let's go ahead and finish our hyperbola. So from the first vertex, I go up and to the right, down to the right. And then from the second vertex, up and to the left, down to the left. And there it is. There's our hyperbola with all the given information. All right. All right, next one. So once again, work with all the information it gives you, plot everything, let's do it. So vertices given are negative 4, 0, and 4, 0. So let's plot that. Negative 4, 0, and 4, 0. Vertice 1, vertice 2, which means that the center is definitely right in between those two vertices. Okay, so there's our center. All right, one thing is for sure is that A is going to be 4. Okay. Oh, and another thing for sure is that, well, the vertex, the center, the vertices, and the center all lie on the x-axis, which means we are parallel to the x-axis. Which means this has given us more than enough information to know which equation to use above. All right. Well, we're not given much information other than that we have an asymptote at y equals 2x. So we have to figure out, what do we do with that important piece of information? Well, since we know we are parallel with the x-axis, we get to use all the information above. But more importantly, let's look at the asymptotes. So they give us y equals 2x. And for this asymptote, we know that if you look at the equation, well, I guess I'll write everything out, right? So we use that asymptote equation, y minus k equals plus or minus b over a times x minus h. We know from below that our center is 0, 0. So this means that we'll get y equals plus or minus b over a times x. Okay, which means it's just y equals plus or minus b over a x. Well, what we know from below is the value of a. What we don't know is the value of b. So how can we find that value of b? By using this asymptote that's given. Well, we know that they're giving us 2x, So what that means is, if the formula for the asymptote is, so if we just use this part, the b over a, right? And I'm going to call this solve for b. So we know that we're given 2x. So all we have to do is take this part, b over a, and set it equal to the 2. All right. Well, like I said, we know the value of a. From below, the value of a is 4. This means that you can plug that value in, and we'll get b over 4 equal to 2, and therefore, b is equal to 8. So now we know a, now we know b, which means now we can find c. All right, so we can do that all over here. So a is 4, b is 8, and now we take this equation, b squared equals c squared minus a squared, and we solve for c. So if you rearrange that equation, you can get c squared equals b squared plus a squared. All you have to do is add that a squared over. So c squared equals b squared plus a squared, which means c squared equals 64 plus 16, which means c squared is 7480. And then you square root everything, and c is going to be plus or minus 4 square root 5. Which means c, if I change that, is approximately 8.94. Okay, cool. Let's go ahead and find our foci and find our minor points, since we now know the values of a and b. All right. So b is 8. So from the center, we go up 8 and down 8, which makes that our minor points 1 and 2. And then c is 8.94. So basically, from the center, you're going to go out 9 units. So I'm just going to put it at 9. And there's our focus 2, focus 1, however you want to label it. Okay. And then, of course, let's go ahead and draw our little fundamental rectangle. Okay. Let's fill in the rest of the pieces. We know we are parallel to the x-axis, so we know which equation that we can use. We're using that first one. So if we write everything, we're going to have our center is at 0, 0 from the graph. So it's going to be x squared over a squared, which is 16, plus y, not plus, oops, minus y squared over b squared, which is 64, equal to 1. Okay, fill in the rest of the pieces and graph it. That's it. So center 0, 0. Foci are at, I'll say, plus or minus 4 square root 5 and 0. Vertices are at plus or minus 4, 0. Minor points are at 0 and plus or minus 8. And it already gave us the asymptotes, but if you want to write them again, asymptotes are at y equals plus or minus 2x. Okay, which means that our asymptotes would cut straight through the center and the corners of our fundamental rectangle. And all we have to do is follow them, and our parabola will go up and to the right, down to the right, and the other one will go up and to the left and down to the left. And there it is. All right, not bad. Like I said, plot your pieces, know what you're working with, and that'll give you enough information to tell you which equation you need to use. Okay, put all those pieces together. All right. Now you know what time it is. We are now given the general form of a hyperbola. And in order to put it into standard form, guess what we have to do? Complete the square. Okay. So with hyperbolas, how you want to write everything depends on how you want to organize everything is look at your x and y's. Look at those variables. Now, whichever variable, so x squared or y squared, whichever variable is positive, you will put at the front of the equation. So when I say that, look at the equation, and you have a negative x squared and a positive y squared. Now compare that to the equations above. Look how they lead off. You know you're going to be parallel to the x-axis if your x's are positive and your y's are negative. And then you'll know you'll be parallel to the y-axis if your y's start out positive and your x's are negative. So when rearranging, the big giveaway is which squared term is negative. That should tell you which one you should put in front when rearranging, which means since 4y squared is positive, that's going to lead in front. So we are going to rewrite it as 4y squared minus 16y, and of course, put your like terms together, minus x squared minus 2x, and of course, move the constant over to the right. All right. And now we are going to do the completing the square process, which we can't do it just yet because these have to be in the proper format. And remember, the proper format for completing the square, one of the main parts is the leading term must always be positive 1. So that means on 4y squared minus 16y, we are going to factor out the 4. which will leave me with y squared minus 4y. On negative x squared minus 2x, we're going to take out a negative 1, which will leave me with x squared plus 2x. All right. We have now put this in the proper form because the leading coefficient of both inside polynomials is 1, which means we can now complete the square. So for this one, CTS, take half of negative 4 and square it. We will get 4. All right. And then for the next one, your CTS, complete the square. You take half of 2 and you square it. Okay. Now, the next steps are to add in those numbers to both sides. So we'll get 4 times y squared minus 4y plus 4 minus 1 times x squared plus 2x plus 1 equal to negative 11 plus, now remember, usually the number would be 4, but since this 4 is waiting on the outside, you must multiply. How did I get that out? Okay, I'll get there in a second. Okay, you must multiply that number by 4, so it's actually going to be 16. Plus, and once again, it would be 1, but since there's a negative waiting out front, it's going to be negative 1. All right. All right. So we've added the 16 and added the negative 1 to the right side, which means we now must clean up. So remember, whenever you complete the square, these trinomials become perfect square trinomials. So we end up with 4 times y minus 2 squared minus x plus 1 squared equal to, what is that? Negative 11 plus 16, 5. 5 minus 1, you get 4. Okay. And then to put it in its proper form, divide by 4. And we end up with y minus 2 squared over 1 minus x plus 1 squared over 4 equal to 1. Which means now compare that to the equation above, and this one looks exactly like the second equation. So we get to use all of this info to fill out what we need, which means we now know the values of A and B, which means we can definitely find C. So A is going to be 1, B is going to be 2. We don't know C, so we will use that formula again, the B squared equals C squared minus A squared. If you rearrange it for C, then just add that A over. So C squared equals B squared plus A squared. And C squared will be 4 plus 1 which means you'll get c squared equals 5. And once again, c equals plus or minus root 5, which means that we get square root of 5, which is again 2.24. Okay. And now we have A, we have B, we have C. We even have the center from the hyperbola equation. And no matter what, comparing them, H still belongs with X and K still belongs with Y. So the center is always going to be HK. So with that being said, we can fill out our center already. Is -1, 2. So if I wanted to plot that, -1, 2. There's my center. Okay. Also, something to notice is that since it starts with y squared, we are now parallel to the y-axis. Okay, which means if A is 1 from the center, we are going to go up 1, down 1. There's vertex 1, vertex 2. And center, of course. Okay, and then since B is 2, we go out 2, left 2. Those are my minor points. 1, 2. And then for my foci from the center, I go up 2.24, 1, 2.24, and down 1, 2.24. And there is my foci. Foci 2, foci 1. And let's go ahead and make our fundamental rectangle. There it is. And now let's fill in the rest of the information. Center was there. Foci output at, it went up, so -1 and 2 plus or minus the square root of 5. Vertices were at -1 and 3. And -1, -1, 1. There we go. All right. Minor points were at, what do we have? 1, 2, 3, -3, -2. I mean, -3, 2, and 1, 2. All right. Last part is the asymptotes. Okay, and this is going to be y minus k equal to plus or minus, and from the above, it is a over b this time. I'm probably in the way. A over b. So a over b times x minus h. Plug in what we know, and we'll get y, what are we at? 2. So y minus 2 equal to plus or minus my a value of 1 and my b value of 2. So plus or minus 1/2 times x minus 1. And we get y minus 2 equal to plus or minus 1/2 times x minus 1. There's the equation of our asymptotes. Now, go ahead and draw them, cutting through the center and the corners of your hyperbola. And now we will graph. Oh yeah. There we go. And that's what a parabola that is parallel to, sorry, I keep saying parabola, hyperbola that is parallel to the y-axis looks like. Whew, lots of information. Okay. Hey, look at that. Last one. Okay. All right. So we are given vertices at 1, -3, and 1, 1. We're also given an asymptote. All right. So vertices at 1, -3, and 1, 1. Let's plot those. 1, -3, and 1, 1. So vertex 1, vertex 2, and of course, if you know where your vertices are, you know that your center is right in the middle. So 1, 2, 2, right there. There's our center. And also, looking at this now, the center and the vertices are parallel to the y-axis. Parallel to the y-axis. All right, and then another thing given is the distance from vertex to center is a. So now we know that a is 2. Okay. But now we need to find b and c, and we can find b and c by using the information from the asymptotes. Also, once again, we are parallel to the y-axis, meaning we get to use all of this information. Okay. So, once again, using the information from the asymptote, well, if you looked at it, that gave us the center as well, didn't it? It had y plus 1 and x minus 1, which means our center was at 1, -1. Wonderful. Okay, but we know where our center is already. We need to find the values of b and c since we know a. So compare this equation to that equation. And again, the only piece we actually need is this 3/2 and that AB. Putting these equal to each other will help us solve for B since we already know the value of A. Okay, so we're going to call this solve for B. We take the value that's here already, 3/2, and set it equal to the part of the formula that represents A over B for the asymptote, A over B. All right, and one thing is for sure, we know the value of A. A is 2. So go ahead and plug that in. So this becomes 3 over 2 equals 2 over B. All right, and now solve for B. For this one, you could just cross multiply, right? And you'll get 3b equal to 4, where b is 4/3. Oh, man. Okay. So this means now that A is 2, B is 4/3, and we need to find C. So once again, use that formula, B squared equals C squared minus A squared, rearrange it for C, and you get C squared equals B squared plus A squared. All right. And we get C squared is going to be B squared, which is 16/9, plus A squared, which is 4. Put those fractions together. 16/9 plus 4. We get 52/9. Now square root both sides. Oh man. We get plus or minus, and I think 52. Let's see, second square root 52 is 2 square root 13 over 3. Oops. All right. So second square root 52/9 is 2.4. Hey, not bad. .4. Okay, which means we now know the value of A, the value of B, and we can find our foci and minor points. And B is 1.33 repeating, right? Okay. So since we are parallel with the y-axis, to find the foci, we'll go up 2.4. So 1, 2, and then somewhere around there, and then 1, 2, and somewhere around there. Those are my foci. Foci 1, foci 2. And then to the right, 1.33, so I'll put that there, and to the left, 1.33. Let's solve off. Let's see. 1.33, yeah, right there. Okay, fundamental rectangle. And of course, minor 0.1, minor 0.2. Okay, put it all together. We have all the information we need. All right, we know our center is at 1, -1. So if we put this formula together, we're going to have y plus 1 squared over a squared, which is 4, minus x plus 1 squared, or is it minus 1? Might have it backwards. Let's see. Yeah. It should be -1. So that goes down. And then I think that's minus as well. Let's see. 1, -1. 1, -1. So that should be minus, plus, minus, plus, minus. Okay. There we go. Okay. X minus 1 squared. Let's write 1 down 1. over b squared, which is 16 over 9 equal to 1. Okay. Now, I don't know if it'll take this as an answer because you can reciprocate this fraction. So if we can do that, we'll have y plus 1 squared over 4 minus 9 times x minus 1 squared over 16 equal to 1. Okay, and all I did was reciprocate that fraction. Now let's fill in the rest of the missing pieces. That'd be 1, negative 1, okay. See it? And once again, center is at 1, negative 1. Foci are at 1 and negative 1 plus or minus, what was it, 2 square root 13 over 9? Or 2.4. Vertices are at 1 and negative 1. I'll just put them in. 1, 1, and 1, let's see, 1, 2, 3, 4, negative 4. All right. And then foci, minor points are at negative 1. Oh no, those are difficult. All right. So this is at 1 plus or minus 4/3 and negative 1. And asymptotes already given at the very top. So we are good. Okay. I mean, that could have been negative 0.33, negative 1, and 2.33 and negative 1. All right. So then go ahead and draw the asymptotes cutting through the center. And just follow our asymptotes up, up, and down, down. And there it is. All right, those are hyperbolas. Once again, know the information it's giving you, know how to use it, know what equation it belongs to, just know how to work all the pieces overall. Nothing too different from the methods we did on parabolas and ellipses, hyperbolas, same exact methods. Just know the pieces and know where they fit in the equations. Okay, that's it. Hyperbolas.